All right, and today for section 9.4, we're going to be talking about the two proportions, okay? One of the big deals is that you need to take a look that your hypotheses are going to now switch from mu1 equals mu2 to be p1 equals p2, right? So we have proportion 1 for proportion 2. Another big deal with your formula, I'm not certain why I did this, but I put this in parentheses up top. It doesn't really need to be, so I rewrote it without the parentheses. You're going to have proportion 1, sample proportion number 1 minus sample proportion number 2. But now what we've got going on is we have this thing called P bar. Okay, P bar is a pooled proportion. We're going to get our P bar, and I'll show you as we work through it. It's right here. If P hat 1 is you divide these two numbers, and P hat 2 is you divide these two numbers, you're going to take the two numerators and add them together as one big numerator. And take your two sample sizes and add them together as one denominator. And then you're going to do this divided by this to get your P bar. Your Q bar is 1 minus P bar. Or you could look at it as P bar plus Q bar add up to 1. All right? And I'll go through it with you and we'll talk about it, all right, as we're going through. So as we look at this, our P value, we know for proportions, always comes from norm CDF, so that's old. Same concept as from last chapter. So if we look at number 1, this was, I actually made this problem a long time ago, so you know it's funny because now vaccination rates are like all the talk, right? But for this is just could be for anything generic, okay? So in a nursing home study, the researchers found that 12 out of 34 small nursing homes had a vaccination rate of less than 80%, while 17 out of 24 large nursing homes had a vaccination rate of 80%. And alpha equals 0.05, we want to test the claim that there is no difference in the proportions of the small and the large nursing homes with resident rates of vaccination rates of less than 80%. So what we need to talk about, let's just go through the data. Okay, so your small nursing homes, the P hat was 12 out of 34. So when I divide that down, I get 0.353. My P hat 2, the large nursing homes, were 17 out of 24, which was 0.708. To get your P bar, what you do is you take your two numerators and add them together. Take your two denominators and add them together. So you're going to get now 29 out of 58. This one just happens to be 0.5. So then your Q bar is 1 minus P bar. So 1 minus 0.5 also gives you 0.5. It just happens that the numbers I picked out happen to be 0.5, but it doesn't always work. It usually does not work out that way. So then from here, it's going to be the same concept. We're testing that there's no difference in the vaccination rates. So no difference means they're equal to each other or they're not equal to each other. I have small nursing homes, large nursing homes. Okay, my formula, we have, remember it goes P hat 1 minus P hat 2 divided by, and then this whole bottom is in a square root. So divided by, so P hat 1 minus P hat 2 divided by bar, square root, P bar times Q bar, parentheses 1 over N1 plus 1 over N2. If you take a look in your calculator, okay, if you want to practice typing that in, you could do your fraction. You could do 0.353 minus 0.708 over square root 0.5 times 0.5 parenthesis 1 divided by 34 plus 1 divided by 24. When you press enter, it should look just like this, right? They should be of the same setup. And there we go. Our z is negative 2.66, which means that when we do our p-value, right, we're going to have, well, here we can just go through all of it, we're going to have norm CDF from negative infinity to the negative 2.66, which gives us this, but we have to double it, so our p-value is 0.0078. From here, we know that that's less than our alpha, which means we reject the null hypothesis, okay? The proportions are not the same, okay, or there is a difference. Between the small and large nursing homes. All right, so if we do a couple more to work together, In a sample of 200 surgeons, 15% thought the government should control healthcare. In a sample of 200 general practitioners, 21% felt the same way. At alpha equals 0.01, is there a difference in the proportions? So if we jot down our information, okay, we've got 200 surgeons, p hat 1 is 0.15. We have 200 practitioners, p hat 2 is 0.21. So when you go to do the p-bar, you need the tops and the bottoms of the fractions. This time they gave us the percentages. So you just need to work backwards to get what the fraction would be. So like if you take a look here, if you have 15% is equal to what over 200, well, you could just do 200 times 0.15. 15% of 200 is 30. So the numerator would have been 30. Same idea over here, 21% of 200 is 42. So 42 divided by 200 is what would have given us that 0.21. So for this problem, to do your p-bar, q-bar, you need to like go backwards a little bit, right? Because p-bar is the numerators added together divided by the denominators added together. So we need to figure out what they were because the problem gave us the percentages, which is no big deal, okay? So now you have 72 divided by 400 and you get 0.18. So if p-bar is 0.18, that means q-bar is 0.82. You don't have to figure this out right at the beginning. You could figure it out when you're doing the formula. That's okay too. Doesn't matter, whatever you're comfortable with. All right. So if we take a look here, it's saying, is there a difference? Which means equal, not equal. Just a coincidence that these two problems were both equal, not equal. It doesn't have to be that. All right. And your formula, z equals p hat 1 minus p hat 2 divided by big square root p bar times q bar, parentheses 1 over n1 plus 1 over n2. Guys, practice typing this in your calculator. You should get this, okay? Which then means that when you do norm CDF from negative infinity to negative 1.56, you get this. You're going to double it. You get 0.1188 for your p-value, okay? Which is definitely greater. So that means we can't reject it. So even though these weren't the same, right, 15 and 21% are pretty far off, we didn't have the right data to say that, yes, we can conclude that there's a difference. So we cannot conclude that there's a difference in the proportion of opinions. 15 and 21% are different, but they're not far enough apart to say that they're like mathematically, formally conclusive. Okay, so right now what I'd like you guys to do is try number 3 on your own. Okay, read it, set it up, get all your info. Okay, really try, like pause the video, because that's how you're going to know if you're doing this right or wrong right from the beginning. Okay, and then here are my answers. So as you check your work, careful, it says, can it be concluded that Philly mail carriers are bitten more often than Cleveland? I had put Cleveland first, Philly second, so it was actually a less than if this is more than this. If you had written them in the other order, that's fine, then it would have been greater than, and you'd have these reversed. This would be the positive 1.04, it'd be a right-tailed test. But you could, so you could do that, that would be fine. And I have this as my answer. If this doesn't make sense, or if you have any questions about any of the details, please make sure you ask in class, our next class period. All right. Good job today. I hope you took great, nice, thorough notes. You have all the samples written down, and I'll talk to you soon.